Hello, dear students. You remember in the content of the last online class session, yes, remember lastly say focus the attention to the studying. It is what in the the memory of the design computer. In the scenario, say an architect found such a projection. It corresponds to the view of a machine element. Okay, and that architect just decided to use the same geometry, okay, for shaping a little house or shaping a certain platform. The geometry is the same, but the size is not. Well, the projection is that of a little machine part, machine element, but say the other object is a house or platform. It is say that in size 100 times bigger or 1000 times bigger, depending on the case. Geometry is the same, but the size is different. Yes. In the scenario, it was the case, and then I educated you on scaling technique, scaling method. Okay. Well, to save time and effort, if the geometry is the same but not the size is to be different than the size of the object its projection is available in the memory, then yes, to save time and effort, change the size of the projection. In the given example in the content of this week extends to the 13th of April to the 19th of April. Yes, this is the online class record. If you watch the video film one more time, you can see that it is the subject in the content of that class session, as the last topic for that meeting time. Okay, remember saying that in the end this projection, after resizing it, will be just a sketch to use for creating the model of that house or the platform. So if it is going to be a sketch, then no need to sketch to use for creating the model of the object, then not necessary to have paper simulation. Okay. If it were the projection engineering drawing, then yes, it is always recommended in the format it exists, have a paper simulation, and when you take the printout, have the things, not only the projection, but also in the format, necessary things, title, block, margin lines, etc. But if the figure to have is just a sketch or just the one to have the necessary region to apply thereafter the solid model creation process, then no need to have the paper simulation. Remember I said so. Hide the paper simulation instead of deleting. Who knows, in future the same projection may be required to use, necessary to use. So do not delete the paper simulation, but turn the length of the layers off. Okay, if you have symmetry axis not necessary to create the model of the object, so hide them. And then I said that to be able to resize it, well, select all using windowing method. Okay, and then while the blue boxes are still in the screen, right click the mouse, and from the menu it will appear, select scale option, and then well, indicate a certain point. Well, here system asking base point, indicate a point. About that point the projection will be resized. That point will stay at its place. All the other things going to be shifted to their new positionings in the new size. Which point you like, you may indicate. For instance, indicate this corner. And then into this box, write the scale factor. I said 100 times, for instance, and then press enter. That is it. Remember, this is just an example from the content of the previous class time or corresponding video record. Now this projection is 100 times bigger. The scale method, the assign scale, is not applied on the length of dashed lines. So I also inform you, notice you that it is so. Well, if you need to see the projections of hidden features as distinguishable along their line of actions via having enough number of dashes, then you should manually change the length of the dashes, writing this command lt scale, you know. Okay, and then well, from the list it will drop while you're writing this keyword. Bring the cursor onto the one, it is lt scale. With a click, start the scaling process to assign a new scale for the length of the dashes. Okay, 100 times increase the size of projection. So to be able to find the dash lines in the say the dash of dash lines, length of the dash length of the dashes of the dash lines in the suitable reasonable order, write the same scale factor, because scale factor, new scale factor, while sizing the projection to set it to the new order, is not applied for the length of the dashes. So writing lt scale command and writing the same scale factor and pressing enter can find the dashes along the dash lines, enough number of dashes, I said. And then, well, then sure, this is 100 times bigger than the existing one in the archive of the company, in the scenario I said. And then remember, transfer this projection to Inventor, and over there in sketch mode have that drawing. It is going to be by definition the sketch, and using that sketch we created the model of the main component of the assembly. Assembly is a platform, it is a structure, and say that in the example it is the main part of the, here it is in Inventor, the main part of the assembly. It is a component and it is the main part. Yes, the floor, okay, these are looks like towers, the base of towers, and these are walls, and in the example these are the legs, supports, okay, supports of the platform. Okay, well, time couldn't be sufficient to complete this exercise. It was the time to leave the online session. Well, in this video record, after making a review and underlining a certain important tricky detail, okay, one more time, then well, say that continue on this exercise. Okay, it is a platform with some walls, but how about windows? I want to answer this question. Bringing different cases to the interest. But before doing this, well, here I want to one more time underline. If the existing projection has been drafted applying classical method, well, you can directly apply scale process to resize it. bigger or smaller. But if the projection, here it is the projection, it has been drafted applying modern method, then yes, existence of some dimensional constraints prevents us from resizing. I want to demonstrate that it is true, and then remind you on the shooting method on such a problem, such a trouble. Well, this projection is the one, it has been drafted applying modern method. Sure. Okay. Well, hide the paper simulation. No need to use the paper simulation at this stage in this example. And then apply a resizing process. I selected all, click OK, and then you see dimensional constraints are shining together with the blue boxes. Okay, well, attempt to resize it. Selecting, right click and then select scale option. And then yes, indicate a point as the base point about which the selected things gonna be resized except the length of dashes, you know. And then into the box write 100, for instance. Press enter. And then zoom extends. You see a very strange result. Well, the boundaries, some of the boundaries as if exploded. And you see if we make zoom in, can see some of the others in their original size. So yes, failure, you see. Applying the scaling process directly onto the drawing, it has been drafted applying classical method without any difficulty, managed to resize it. But when we repeat the same process on the one it has been drafted applying modern method, we vanish. Why? Because of the existence of dimensional constraints. Say oops, undo, and then, well, before applying the sizing process, say undo. If you know that, or if it is your doubt that after applying the process and vanishing, then sure, be sure that the reason of such a failure is the existence of dimensional constraints. But before making such a trial, if you know that it is the projection, it has been drafted applying modern method, or if it is your doubt that you wonder which one is true, then yes, before applying the scaling process, select parametric tab and then clicking on show all button, check whether there are dimensional constraints. Actually, this is the controlling technique, whether which method has been applied for drawing such a projection or drafting such a view, modern or classical. If there are dimensional constraints as at the background, then this means, or geometrical constraints, this means the method it has been applied is the modern method. For instance, show all, and then see the geometrical constraint symbols, concentricity, horizontality, verticality, etc. Note that this drafting has been drawn applying modern method. Okay, and then to be able to satisfactorily resize the projection, the thing to do at the beginning is that bring the cursor onto dimensional constraint, click, and then delete it, pushing delete button. Well, if you do not delete the dimensional constraints, you cannot resize the projection, because these are constraints, and those will prevent us or prevent the software from changing the size of the projection. Selecting the dimensional constraints and deleting them, pushing delete button. It is a common deletion technique, you know. Select and click on delete button of the keyboard. Yes, geometrical constraints may exist, but the dimensionals are to be deleted, and then the rest. Select all, right click the mouse, and then scale, indicate a certain point as the base point, and then write the scale factor. Example, 100 times bigger. And then say that, zoom out to call the figure back to the screen. Yes, now there is no spreading out. All the things are in new size, except the length of the dashes, of course. To be able to have the dash lines in the order to have along the lines enough number of dashes, you know, we need to write lt scale comment, and then into the box write the same scale factor. If you change the size 100 times, then say that use the same factor for having the length of dashes in the reasonable order. Yes. Okay, after reminding you on scaling technique and then underlining that the projection is the one it has been drafted applying modern method without deleting the constraints, cannot resize it, then in this video record, yes, as I said at the beginning, I want to talk about the windows. Okay, of course not windows, but I should say window opening, door opening, window opening, because it is not an assembly. You know, in course Mac 113 or CVE 101, in the content, students can find the components only, single objects, not assemblies. While assemblies are subjected in the second computer-aided design drafting course. It is called in Northern Cyprus campus, Middle East Technical Northern Cyprus campus is Mac 114. Okay, interested students are welcome. Okay, registering to that complimentary course, you can learn all the necessary details on assemblies, assembly modeling. Okay, now here, so that not window but window opening, not say door, it is a sub-assembly door, you know, frame of the door, if there is a glazing, glaze, say handle part, the lock assembly, etc., and the hinges, it is a sub-assembly. But say here, in this example, since it is not to be an assembly, it is because assemblies are out of the course content, well, say that it is the main component of the platform, and the empty features, I'm going to create them, just the openings, window opening, door opening. Okay, start dealing with the easiest case first. Well, remember, I already very briefly, when just talking about the structure of Inventor and saying that let us create the first module of the semester in the environment, I briefly talk about it, I remember. Well, to be able to draw the necessary sketch over an already created surface, okay, simply indicating the surface and right-clicking, indicate the surface, right-click the mouse, and this menu will appear in the vicinity of cursor, and on one of them it is written new sketch. Clicked on new sketch and then start the sketching stage. Sketch plane will coincide onto the indicated surface of the object, and then draw the sketch, I said. Yes, it is the thing to do to be able to have the necessary profile, necessary sketch over a certain surface, and thereafter to apply the model creation process. It is the thing to do. But left clicking and right clicking and clicking on the button, you can take a sketch right and then deal with the sketching stage if and only if the indicated surface is a flat surface. If not, for instance, this is a curved surface, you see, cylindrical surface. Indicating that surface, try, I broke the cursor onto surface, left click, right click, and then say new sketch. Yes, repeatedly making clicks on the surface, but there is no response. But if I indicate the flat surface, then yes, I almost immediately find the buffer in sketch environment, ensure that the indicated surface, which is a flat surface, is coinciding with the unlimited sketching plane. Okay, the plane just highlighted, thanks to my allowance of course, highlighted by the grid lines is the sketch plane. Okay, the two thick lines, this and the others, are coordinate lines, and the intersection point of those is the origin of the coordinate system. You know this. But no doubt the one cross-hatched, say the one hatched with grid lines is the sketch plane, and sketch plane coinciding with the selected surface. Okay? Yes. If the surface is a flat surface, without any difficulty, you can start the sketching stage. Okay. Well, to be able to create the window openings over this part of the wall, say that in the example there are two windows and a door opening, two window openings and one door opening. Okay. Yes, start. How the openings can be created. Select the surface. On the surface, the edge of the window openings, edge of door opening, find their places at one of the sides. Indicate with the left click, right click the mouse and click on new sketch button. Okay, and then create a rectangle. In this example, rectangle, because window opening is a rectangle in shape, because the window is a rectangular window in the example. Arbitrarily create them. Okay, and then arbitrarily create one more rectangle. It is in the case to have the door opening. Okay, there should be a door to enter to this platform. Okay, but in this example we are going to have the door opening but not the stairs. Okay, from the surface of the earth to step on to the platform, there should be a ladder, stairs. Well, here if it were ascended, then it might be the complementary thing to exercise. Create the stairs and then assemble it. But here in this example, only the openings. Okay, and then arbitrarily created the necessary sketches. Okay, I should locate them, I should size them. In doing this, I'm going to use the edge of this wall as one of the references. Okay, or not the edge of the wall tip, but say the surface of the floor. You see, this is the floor of the platform. Okay, I'm going to use the platform as one of the reference to locate the window. From the platform, window is boundary of the window opening is at a certain distance. How much? Okay, as the designers say that we know the answer of that question. To be able to show the floor as the reference, need to have it as projection. But to be able to have the projection of the boundaries of a surface, never clicked on surface. Apply project geometry process, clicked on project geometry button, and then indicate surface. Never indicate surface. If you indicate a surface, then the projection of the surface is created. And for instance, if you need to show a region over the surface you drafted, thereafter to create the model of a certain feature, then you vanish, as already highlighted or noticed you. Never apply project geometry process for the surfaces. Apply the process for their boundaries. I'm going to have the projection of this boundary of the floor. Well, I apply the process, and I am sure this green line, it has just been created by the software as the output of this process, is the projection of that boundary of the floor. It is in the sketch plane. And since sketch plane is coinciding with the selected surface of the wall, sure, this green line is on the surface. So it is as if a real line. It can be used as a reference. The other reference is this boundary of the flat surface in this example. Okay, with respect to this boundary, with respect to that projected line, I'm going to anchor the sketches and thereafter size them. Dimensional constraint. From the projection of the edge of the floor of the platform, click to the lower boundary of this window opening, say that distance is normally is to be a standard distance, say that it is 900. Okay, near to 1 meter. The unit of measurement in this environment, since I selected say ISO template, ISO into metric unit system, it is in millimeter. It is millimeter. So input it. Now it is 900 millimeters away from the surface of the floor. And while similarly locate this rectangle with respect to the same reference. Okay, say that it is at the same level, 900. Okay, with respect to this boundary of the flat surface, okay, this boundary of the window opening, say that is 1300 millimeters away. Okay, from here to there, distance is equal to, say that 7,360. Yes. These are anchoring distances. Well, for the door opening, well, it is lower boundary and the edge of the floor should be 0 millimeters away. Okay. And then, well, size the door opening from this reference, use the same reference to the boundary of the door opening. Distance, let's say, is equal to 4,500. Okay. And then width of the window. This is the sizing stage. After bringing the sketch to the correct places, either with respect to each other or with respect to the selected references, then, well, in the order, sizing. You see the method which I am applying to have the necessary sketch is the only method to use in new generation software. It is the modern method. Arbitrarily create and upload the constraints. Well, this is the dimensional constraint. Say that the width of this window is 1,500. Height of the window opening is equal to, let's say, 1,000. Okay. Similarly, the size of this is 1,500. Okay. And the height 1000. Okay, and size the door. From here to there, the width of the door is 1500, let's say. It is a standard distance. Okay, the height of the door opening, say that 2300. And then finish the sketching stage. Yes, you see, without any difficulty, managed to have the necessary sketches and the regions profiles bounded by those. Okay, then the rest, apply the process extrusion, because opening is a right prismatic prism in shape, so extrusion process is the correct process. Select cutting option, and then the rest, indicate the profiles, this and the other. Well, the thickness of the wall 200, so as the cutting length, minimum right 200, and then say OK. Yes, here we are. We have a door opening and 2 windows openings. Okay. Yes, after each stage, don't forget to save the file. Okay, save the file, update it. And then a relatively difficult case. Now say that there is a window. Okay, that window is over this surface. To have over here, need to have over here. You know the difficulty. Indicate, left click, right click, new sketch. There is no response. Okay, cannot find the sketch plane because the surface, okay, is a curved surface. If the surface is not a flat surface, you cannot via simply indicating, you say I broke the cursor and repeatedly clicking the mouse. There is no response. Buffer is still in 3D environment, not sketch mode. What can we do? Press escape button because going ahead is impossible. Now, since sketching stage can be started indicating a flat surface, then try to find a flat surface. Okay, if at this site there is a flat surface, not of course necessary just very close to this surface, it is the surface for having the cutting, okay, window opening or door opening or whatever it is in the end, but it may be even at a certain distance. Try to find such a flat surface. In this example, unfortunately, there is no flat surface at that side or at the opposite side to take a sketch right. What can we do? Well, use work plane features, work plane facility. It is not for the first time, remember. In one of the class session, I made an introduction to this facility. Okay, this is the tool of Inventor. Using the tool can have a flat surface. It is not a real surface, it is imaginary, but it can be used as if real. For instance, have such a paper and then take a sketch right on it. Well, if we use this tool, then the created work plane, that imaginary plane, will be unlimited. Well, for the first time, remember, I introduced that facility, introduced you to that facility of software, talking about oblique surfaces. in Inventor how an oblique surface can be created. For the first time, under this title, under that question, I talk about work plane facility. Here, while the suitable option to have work plane, necessary flat plane, okay, to select from this list is offset from plane option. And then I started the process and system asking me, sure, as it is implied from here, you see in the schematic figure for this option, there are two planes, one of them green, the other one brownish or orange colored. Well, the brownish one corresponds in the schematic figure to the work plane. The green one is the surface to indicate as the reference to say that the work plane is parallel. Yes, offset from plane facility requires a flat plane as the reference to indicate, and then the work plane thereafter can be created at a certain distance away as parallel to the indicated one. I started the process, but you see there is no flat surface at that site or in the design of this object to be able to indicate and thereafter draw the necessary sketch. If there were a flat surface, for instance here, study, I started work plane creation process and then say that this flat surface is the reference. Here at this site there is a flat surface to indicate. Okay? Actually, well, say oops and then first focus your attention to this relatively easy case. For instance, you need to create a window opening and the direction of the opening is perpendicular to this flat surface. There is such a flat surface in the structure of the existing one. So no need to use work plane actually. Why? Or say that if the indicate the surface and draw the sketch and then apply the process. Not to have the feature over here, but have the feature over there. Explain what I mean. For instance, take a sketch right on this surface and then new sketch. Well, since the sketch plane is behind of this solid part, you see, sketch plane is coinciding with this surface, but while I'm observing it in this direction, the solid part of the object, which is in front of the sketch plane, is preventing me from seeing the things in sketch plane. What can I do? This is another issue to deal. Well, extend, you see, opening such parentheses on the answer of some difficulties. Well, trying to extend your knowledge, experience on model creation. Okay, what can I do? How can I see the things to draw on the sketch plane? One technique to make the sketch as distinguishable, to allow yourself to see the things on sketch plane, change the visualization style. View tab, visual style, and then select wireframe option. If you select wireframe option, then start seeing the model as if made of banded wires. And then since it is as if wire made of banded wires, or it looks like made of glass, then can draw the profile over there. For instance, say that you need to have a opening not here, but at the opposite side. It's a cylindrical surface, you know, a circular window opening. Okay, yes, I drive the circle and then dimensional constraint from here to the center, from here to the center, anchor, size it, etc. Okay, you may use this technique, change the visualization style. Or alternative technique, one more time select the recommended option, shaded with edges option, and then in Inventor there is one more tool. Whenever the solid part of the object it is in front of the sketch plane, prevents you from seeing the sketch, then either change visualization style or along the status bar in sketch mode find this button. Please follow my cursor and indicating which button on the along the status bar. If you clicked on this button, then Inventor will take the visibility of the features which are in front of the sketch plane. Well, observe the things three-dimensionally and then see what is occurred when I clicked on this button. Now, about to click and clicked. You see the features, okay, of the object, their visibility is taken away from the screen. So, well, thanks to this allowance, I can see the sketch over the selected surface while I'm drawing the things. Okay, and then say that finish the sketching stage. And then what I mean, say my purpose is to create the empty space, not here, but there. Is it necessary to use workplane? No, because, well, I found an existing flat surface. I took a sketch right on it. Okay? But the cutting won't be over here. The empty space or entity, well, here it's an empty space, is to be created over this curved part. Since it is impossible to take a sketch right and draw a sketch over a curved surface, I drafted the sketch over this flat surface and then see the rest. Apply extrusion process. Okay. And then cutting process. Select from this select cutting option and from here two options. Select two option, not true all option, not write a cutting distance, but select two option. Okay, and then, well, indicate the surface. It is to say, apply the process to this surface, from the sketch plane of the sketch to this surface. Yes, apply the process and then say OK. You see, although I drafted the sketch over the surface using two facility of extrusion process, I managed to create the empty space over the curved surface, over the curved feature, within the curved feature. And well, you see the edge of this space is over the curved surface. Okay? But say oops, and then assume that the surface which you selected to be able to create such an entity over within a part, it has not flat surface but curved surface. Assume in this example that a very crowded surface. Assume that over the surface you have lots of things and these are very crowded. Okay? So you don't want to select that crowded surface to draw the necessary sketch, because it is your doubt or afraiding that while you're trying to draw the new sketch, you may confuse the things or interfere the things, say with the already existing boundary lines. So in such a case, can do what? Say oops. Instead of drawing the sketch over the surface, then yes, from here select offset from plane option, and then system asking me on the reference plane. I'm going to indicate the surface as the reference, and then into this box it will appear write an offset value. It is the distance between the indicated reference and the work plane to have. Okay? If you know the distance, write it. If not, then arbitrarily hold the golden arrow and then arbitrarily locate the work plane. The simulated one is the core region of the work plane. Work plane is unlimited if you selected the invoking option from this list. Okay? Well, to be able to create the opening over this curved part, within that curved part, it is not a matter the work plane is close or very away. It should be at the outside or completely at the inside. Okay? But certainly away from the feature in which we need to create the empty space. I located this work plane over here with a click onto this inputting tab or simply pressing enter. This is the work plane. Well, in this scenario, I said that, repeat again. Although it is possible to draw the sketch over this flat surface, thereafter to create the empty space within that curvy feature, but since in the scenario I said that there are lots of things already created to their boundaries, so while in drawing the sketch over this crowded surface, there will be a difficulty. So to make life easier at the sketching stage, that's why I defined such a work plane. I had such a work plane. It is imaginary, but since it is flat, we can take a sketch right on it. Indicated with a click, bringing the cursor to its boundary, right click the mouse and say new sketch. Yes, over the curved surface impossible, but over that flat surface, yes, we can take sketch right. Over curved surface impossible to start the sketching stage. Say that's why I had such a flat surface. And then the rest, create the circle. Why? Because over that surface we need to create such an empty space. Okay? Window is in cylindrical shape. Window opening is like a hole. Okay? In this example, not rectangular window, but circular window. And then project geometry process relative to the edge of the floor, relative to the limit of that surface. These are the references. Anchor the opening, center of the opening. From here to there, say that location dimension is I don't know, 2800. Okay. From the surface of the floor to the center of this window opening, distance is equal to 1200, let's say. Okay? Or little bit increase. Press escape button. I changed the decision, so not 1200. After finishing the execution, now editing, bring the cursor onto the dimensional constraint, double clicking, take a right to replace it with the new one. Say that 1500 is the new coordinate. And then size it, dimensional constraint, indicate the circle, say that the window is in that size. It is diameter 1000 millimeters. And then finish the sketch and apply the process. Yes, sketch is in the atmosphere, but you know the technique. Extrude, cutting mode, okay, and then select 2 option. Why 2 option? Because I don't know the distance. If I use this box to write the cutting value, I don't know the distance from the sketch to the inner surface of this wall, the maximum distance. So think about this difficulty. Cut the material starting from atmosphere, reach to it, and then how many millimeters the distance? extrusion distance. I don't know, but if I use this tool, see the value, select two option, and then indicate the inner surface. It is to say that apply the cutting process within the solid part, okay, till you reach to that limiting surface. Indicate it with a click, and then say OK. Yes, you see, managed to create this empty space. And then if you use a work plane, then no need to keep it as visibility. How you can take it visibility after finishing the necessary thing, of course, bring the cursor to the browser. If you invoke the work plane using this facility, then well, there will be corresponding icon, work plane icon. Right click the mouse to be able to make it invisible. Take the visibility of it from the screen, from the region. Deselect this option, visibility option. This is the good practice. Okay. Here, since the indicated reference, okay, was that, you see, extrusion process always is applied in the direction which is perpendicular to the sketch, plane of the sketch. Since I indicated this as the reference in the first demo for creating such an empty space, drafted the sketch over the surface and then apply the process. And the whole axis of the hole, or say this empty space, became perpendicularly oriented with respect to the sketching plane. Or second exercise, I use this work plane. Okay, sure that the since the sketch I have this sketch over this work plane, applying extrusion process, I created that empty space. Its axis is perpendicular to the work plane, to the sketch plane. Extrusion process, don't forget, is applied in the direction which is perpendicular to the plane of the sketch. Okay, then. Here, I need to create a window opening, let's say empty space. Okay. It should be perpendicularly oriented, not with respect to the surface, or not with respect to such a work plane. It is parallel to that surface of the building or whatever it is. Okay, it should be in another orientation, in other direction. What can I do? Well, one more window opening over here I'm going to create over this surface. Okay. Need to draw the sketch, I know, but at this site, you see, there is no flat surface in the structure of the object to be able to direct, to be able to select, or to be able to direct the work plane. Yes, select offset from plane option, and then system asking a flat surface as the reference. This is not a flat surface. This is not a flat surface, so what can I do? Such a case, well, try. If the direction of the opening is perpendicular to coordinate plane, well, the one defined by YZ, or the one defined by XZ, or the one defined by XY. You know, in this 3D environment, we have a Cartesian coordinate system. It is in the default configuration of the software. It is defined, and this symbol at the corner just to remind us that it is true. Okay, then after starting the work plane invoking process, selecting offset from plane option, and then try to find a flat plane. It is parallel to the necessary work plane. This example, there is no such a flat plane to indicate as the reference. Then use coordinate plane as the reference. Okay? In case, say that there is no flat surface to indicate as the reference, okay, for having the necessary work plane. So try to use coordinate plane. Bring the cursor to the browser and over there find origin folder. Click on the associated cross. In origin folder, can't find the icons. Those corresponds to coordinate planes and coordinate axis. Bring the cursor onto this plane option, coordinate option, and then you see the highlighted one is the core region of YZ plane. For the first sketching stage, when we clicked on Start 2D Sketch button, it is one of the planes simulated by the software at this stage. YZ plane, XZ plane, XY plane. If the sketch, plane of the sketch, is to be parallel to such a coordinate plane, okay, then okay. That is the solution. Bring the cursor onto this coordinate plane icon. It corresponds to the simulated highlighted one. It is the core region of that coordinate plane and indicated with a click as the reference. And then, well, into this box write the offset distance. Well, here after indicating the reference, you see we have the indicated reference in the simulation and one more plane. Okay, it is the work plane. Well, if you're going to locate the work plane over here, then into this box write the offset value, the shortest distance between the reference plane and the work plane, as positive. If you're going to have the work plane at the opposite side, then write the offset value as negative. Here my purpose is to create an opening over within this cylindrical wall. So since my purpose is just to create the empty space, then not necessary the work plane is where. Do not pay attention. But of course the work plane should not cross the wall. Okay? Either it may be completely at the opposite side or at this side. So dragging the work plane, holding the head of golden arrow, dynamically bring it to a suitable place and then clicked on this OK button. Yes. Here in this example, saying that, yeah, that's the opening. Okay, the direction of the opening is perpendicular to this coordinate, to the coordinate plane. Okay, if it is the case, then yes, you can indicate the coordinate plane for having the parallel work plane. And over this work plane, take a sketch, right, and then draw the sketch. Yes, go ahead and do it. Left click, right click, new sketch. And then yes, I'm going to create the opening relative to the surface of the floor. So applying project geometry process, have it as image, the image of the edge of the floor, of course, and the other reference will be this limiting surface of the cylindrical surface indicated, and then say that opening is a rectangular opening. So create a rectangle and then location dimension relative to the floor for the lower boundary of the opening is 900, let's say. Okay, and from here to there the distance is 600. Okay, and the width of the rectangular window is 1600. Okay, height is equal to 1000. And then finish. Yes, the sketch is in the atmosphere, but here sure, extrusion process will be applied in the direction which is perpendicular to this plane. And don't forget, this plane is parallel to the coordinate plane. So the if it is the case, create the empty space within this wall. Okay, the direction of the empty space is perpendicular to the coordinate plane. If it is the case, the requirement, then it is okay. Start the process, extrusion process, select cutting mode, and select two options because I don't know the distance from the sketch plane to the ending surface of the wall. Okay, indicate the ending surface as the target. Okay, it is to say that apply cutting process. Okay, start from the outer surface, extend the process, cutting process to the inner surface. I indicated the limiting surface and then say OK. Yes. Created the opening over here. How? Drawing the sketch within such an imaginary plane, work plane. OK. Take the visibility of this work plane. And then, well, the last exercise on the subject, how an empty space can be created. Well, say that an opening is required within this curvy feature, and the direction of the opening is not perpendicular to coordinate plane. So, well, start the work plane invoking process, for instance, select this option, and then, well, the direction of the cutting process is to be not perpendicular to this, not perpendicular to that, not perpendicular to the other. Its direction is different. What can we do? Cannot take a sketch right over this surface because it's a curved surface. Cannot indicate the coordinate planes as the reference for having the flat imaginary plane, okay, to draw thereafter the necessary sketch, because the direction of the cutting is in the different sense. It is not perpendicular to this, to the other. So in such a case, see, what can you do? In AutoCAD environment, talking about revolve process, well, already inform you. Say that, yeah, well, why not? Applying extrusion process, we can create a work plane. Now, in this example, one more time, see how it is created. The work plane in this example is perpendicular to the floor of this platform. Okay, take a sketch right over the top or bottom side surface of the floor. It's not so important. Or even, since this tip of the wall is parallel to the surface of the floor, even you may take a sketch right over this boundary, over this surface. Which one you like? Top surface of the floor, bottom side of surface of the floor. See the bottom side. Here is the bottom side surface. Or even the bottom side surface of the legs of the platform. Which one you like? I took the sketch right over this surface. New sketch. Okay, and then draw the line. It corresponds to the edge of the work plane. Okay, edge of the work plane. Work plane, it is in my consideration edge of the work plane. Work plane, orientation of the work plane. Well, project geometry process, and then have the projection of the edge of the rectangular prism. Yes. Apply project geometry process, and over the sketch plane now I have a green line. Okay, with respect to this reference, the inclination angle of the direction of the opening or inclination of the work plane with respect to that reference, say that 10 degrees. Yes. The orientation of the cutting, the direction of the cutting is to be perpendicular to this line. This line is the edge of the work plane actually. Okay. And then finish this sketching stage. The distance between this line, it corresponds to the work plane, edge of the work plane, to the wall is not so important in this example, because I'm going to use the work plane just to achieve cutting. Have the necessary sketch over the surface and then apply cutting process. But where is the work plane? Using this facility couldn't have a suitable option because, well, the direction of the opening is not perpendicular to this, not perpendicular to that, and couldn't find a plane, say, in the structure of the existing part of the object at present. Okay, its orientation is perpendicular to the direction of the cutting. So that's why I'm going to create a work plane. Apply extrusion process. After drawing such a sketch in sketch mode, it corresponds to the edge of the work plane, and then apply extrusion process. But here there is a trick. In the dialog box, click on this button, because automatically when we start the extrusion process, Inventor will be ready to find a closed profile, closed region, to create the model of a right prismatic feature. But here my purpose is not to create a solid feature, but my purpose is to create a flat surface. And also here you see there are red colored exclamation marks, Inventor saying that couldn't find a fresh closed region, fresh sketch, closed sketch. Inventor noticing me, saying that cannot create a prism. I know this. My purpose is to create a surface, to teach to the software that not a solid part but a surface is to be created. Bring the cursor onto this one and change the mode. Click on this and then select surface creation mode. See the symbol on the button now. This is to imply that solid model, but this is to imply that surface. After changing the mode, it is now the extrusion process ready to apply for creating surfaces. Then indicate the sketch with a click. And then, well, either in this direction or in that direction, or symmetrically clicking on this, both of the direction, create a plane. Yes, this plane is not unlimited. It is infinite size. What should be the size of the plane? Since this plane is needed, just to take a sketch right, okay, to coincide the sketch plane, okay, not a matter it is in which size. It is even might be infinitesimally thin, infinitesimally short, small. Okay, just to make it distinguishable, set a certain finite size. Okay. Do not pay attention to this number. It may be in order to make the work plane distinguishable. Okay. You know, this is going to be used for coinciding the sketch plane. Sketch plane is unlimited. So just finish this surface creation stage, and here is my work plane. You see, I created the work plane, not invoked. Using this facility can invoke a work plane. But here I created the work plane and its orientation is correct. This work plane is perpendicular to the direction of the cutting extrusion process. And then on this surface take a sketch right, left click, new sketch. and then the rest. Draw the necessary profile. Say that here we need to create a rectangular prismatic empty space, and then project geometry process relative to the edge of the floor, have it as projection, relative to this boundary of the cylindrical surface. I had the projection of those boundaries to use them as references. Dimensional constraint from the edge of the floor to the edge of this opening, this sketch, distance is 900. Okay, from here to there, distance is equal to 1200 in the example. Okay, the width of the opening is equal to 1500. Let's say height is 1200. Finish sketching stage. And then you see our sketch is in the atmosphere, okay, over the imaginary plane, work plane. And then the rest, start the extrusion process. Now Inventor found a closed profile and offering such a solid prism. No. Select cutting option, okay, and then select two option, because I don't know the distance from the sketch to the limiting surface of the wall. Limiting surface is this inner surface indicated, and then clicked on OK button. Yes, now the direction of this cutting is perpendicular to this work plane, not perpendicular to coordinate plane. You see, coordinate plane is here. See the difference. This is the necessary work plane. This is the coordinate plane. You see, their directions not the same. If it were the case, the direction of the cutting were perpendicular to that coordinate plane, instead of creating such a plane, I would indicate it as the reference, have the work plane as already the exercise for creating the previous one. Yes. Okay, then I focus the attention to the issue from different aspects, starting from the simplest one to relatively difficult ones. I extended your focus. Okay, then, my dear students, finishing this exercise. Of course, good practice is always true. Take the visibility of work planes. Here, this icon, you see it is not blue colored but brownish, corresponds to that plane. Okay, I created that plane applying extrusion process. You know how. Take the visibility. After right clicking the mouse, can find this list, and from the list select visibility option with a click. This is good, and save the file, update it. Okay, finish this exercise, my dear students, ending the record. Stay healthy. Bye bye.